So let's start then. So hello, my name is Gilles Noisette, and I'm working for the Big Data Solution Center for EMEA, putting in action, all the technology I'm going to tell you about. So first, I will just show the picture roughly about the approach, the global HPE approach about big data and how we see it with the enterprises. Then something that is interesting to know that we are contributing to the open source. We are contributing to Hadoop or Spark. And just an example of what we recently did about Spark. Then some innovations regarding Hadoop. So it will be more at the level of the platforms, but I will tell you about some architectures, product, components that you can put, in your Hadoop solutions, your big data platforms. And then something about, something you don't know maybe, that we have also a solution on top of Hadoop to do SQL, but really analytic, SQL analytic. So I will come to this solution before to talk about security. And Sam, it could be interesting to understand what we are talking about when we're talking about security and the purpose and what we can do, what we can offer, who is using it. And once you understand all that, to put this in action after, to use big data, very often you need help. And it is about the services, data discovery services that we are offering. So let's start. So we have what we call transformation areas inside HPE. One is about what we call empower the data-driven enterprise. And the idea is really to have something that is data-centric, an approach that is data-centric to help our customers, to provide everything from services, software, and platforms to our customers. So first, something that is quite new, because the announcement was 1.5 months ago. I don't know if you heard of that, but during the Hortonworks announcement, 1st of March, we had Martin Fink. Martin Fink is the CTO of HPE. Martin Fink, who was announcing, a new, let's say, new features about Spark. And the fact that we are working with Hortonworks to make it open source. So the idea is that the HP labs have been working on Spark and how to make Spark, to make a better usage of the memory. And it works, and we know it works well in memory. But what if, for example, we get a better shuffle for Spark? Is it possible? Yes, no. And the guy that worked on it, and they found an interesting way to optimize the shuffle. And they rewrote even the shuffle in C language for Spark. So you don't need to modify one line of code, but you can take advantage of this to get more performance. And also because they were working on systems with large memory systems, they found ways to optimize the memory usage of Spark. Which means at the end, you have something that is really a standard Spark. We are pushing it in open source, working with Hortonworks to push it in open source and maintain it. And this is really open. You don't need to modify one line of code, but you are getting a better performance. And when I say a better performance, we did testing in the financial services industry. And we found, depending on the type of application, something like a 3-time improvement in terms of performance to 15 times in one case. Real cases from the financial industry. So this is the example of how we can contribute to the open source and what we are doing. Now, in terms of Hadoop, and when I say innovations, I mean we have an approach where you have standard servers. So typically, you know, the DL treaty, traditional platforms. You might know these servers. I think there are servers that most sold in the world. Very nice platform, very well-balanced platform for Hadoop, for example. Not only Hadoop, you know, you can any type of big data application nearly on them. Not sure, not if you need to scale up, but if you need to scale out, this is a very standard platform. A lot of our customers, they love it, and they want to continue to work on it, even for Hadoop. Now, a lot of our customers also, they want Hadoop, they want big data, they want massively parallel processing type of architectures, but they want something that is designed for big data, something that is more dense, maybe in terms of drive, in terms of disks, in terms of storage. And that where we come with what we call the Apollo line of product. And this Apollo line of product is really optimized and created for big data. I will give you one example about that. And it's good to have components, but what about the next step in terms of architecture for Hadoop? What is the evolution of Hadoop? How do we see the evolution with people who are using Hadoop a lot and for some time already? And this is what we call a different type of, a different type of architecture. And this is an asymmetric architecture. I will come back on it after to tell you what it is. And this is a different approach, you know, really something that shows the evolution you might have or need for Hadoop. So we don't have appliances in HPE. We have reference architectures to help people to build clusters. You can build clusters from a few nodes to thousands of nodes. We have customers with thousands, really thousands of nodes with petabytes, 50 petabytes sometimes of data. Depending on the type of node people will choose, you know, you have more or less density and you have more or less computing capabilities of the system. So what matters that we make sure that our systems are working well. And this is the idea of the reference architectures. We want to make sure that all the components in the system working together are doing something that works well for Hadoop and for other big data applications. These are the reference architectures. In terms of density, storage density, to give an idea, you know, it comes from 2.5 petabyte per rack, which is not bad. But depending if you want something nearly 5 petabyte, or if you want something for archive. And this is interesting if you are thinking about doing storage sharing with HDFS. This is available now in Hadoop. And you can put 5 petabyte, more than 5 petabyte in one rack. So we are talking about density. We are talking about efficiency. The Apollo 4200 is a good example of a server which is designed for big data. In terms of density, it is really one of the best ones on the market. And it's not done only, you can use it for archive because you have a lot of drives. So up to 28 LFF drives, big drives, up to 8 terabytes, which means 224 terabyte maximum per node. So this is big. This has been really designed. You see that you have twice the number of drives compared to a DL380. The value of it, really, for some customers, it is really obvious that it is interesting if you divide by 2 the number of servers to manage. Also, you are optimizing the power consumption. Then you are dividing by 2 the number of network ports you are using. Then you are dividing by 2 the number of licenses, of subscriptions you need. And that makes a large cluster a lot more efficient in terms of TCO. The value of this server, it could be used as a standard worker node because you have a core-spinner ratio of 1. So as an example, you can have 28 cores and 28 drives, which is, you know, a rule of thumb for Hadoop. Or you can have more storage and a bit less computing. You can do different combinations for different type of needs. This is a really great and standard server. nothing special, just optimized design for big data, which means it works also for object storage, by the way. And it's something interesting, by the way, we'll get Erasure coding in Hadoop, and it is in June that we will get the first version, I heard. I don't know if you heard or if you know our moonshot offer. In fact, because some of our customers, they are really looking at power consumption, optimization of the power, optimization of the square meters. And these customers who need really to optimize because they are getting more and more data. They need more and more computing. So this is something that has been designed more for computing than storage, but you get something with a lot of power, it's just for you. Because in fact, in this size, you have 45 servers, 45 real servers in 4 use. So if you need, and a very fast interconnect between all the servers, by the way. So if you need something that is really powerful in terms of computing, you need density, you need optimization in terms of power consumption, this is what is needed. I don't tell you every project, people, they want it, but more and more people, they are looking at power consumption, more they are interested. And if we're thinking about the kind of cartridges, because we call a server a cartridge in this case, the kind of cartridge, typically if we have a cartridge with 8 cores, 128 gig of RAM, 2 terabytes of drives, SSD and NVMe, so very fast drives, and two times 10 gig, I think we have something that is quite interesting. So let's see what is coming, but I think we have good news soon about these kind of things, which mean that with this type of computing for Hadoop, interesting if really you need really low latency and computing. In one enclosure, you get 5 terabytes of RAM. You get 90 terabytes of very fast storage for Hadoop. So interesting platform, and you will see just after how we can use also this platform and why it makes sense also. Because now I'm going to tell you about the asymmetric architecture from Hadoop, and after Vertica SQL on Hadoop. So there is one point with Hadoop. If we are in a standard massively parallel processing type of architecture, we know that we can grow very easily, but it's not easy to shrink. So if I want elasticity, and maybe you need, or your customers need elasticity in the cluster, it is a bit hard. Not because of the computing, but because of the storage. Because Hadoop is not designed, I would say, to remove storage nodes. It works, and there are even tricks to make it if you create some racks that are virtual. And really, in terms of operation, it's not done for that. So it's easy to add storage, and that's what they need in general in Hadoop, but not to remove storage. Now, some of our customers, they come, large customers, they came back to us and said, you know what, I would like to be able to be really elastic, to get something that is really elastic. I can grow and shrink as I need. And what about splitting storage and computing? So it's good. It is a good remark because this has been created, the ideas are around 2000, the year 2000. People, they were still at 100 megabit at that time. Now we have fast networking. So what about splitting computing and storage? Maybe it will cost something. I don't know in terms of performance. I don't know what we'll see. But it could be interesting because then I can do whatever I need, on the computing side. Because adding a node or removing a node with just a node manager on it, just yarn on it and the stack of application you are using, it's easy. It's easy to add nodes, to remove nodes. You can put it in the cloud. It is easy. You can do Hadoop as a service. You can do multi-tenancy. So then you have something that becomes a lot more easy to use and to scale. And when you have different workloads, this is nice because you can have different workloads on the same system. This solution has been tested. In the middle, for sure, we have servers that are doing storage. There are storage servers. We have servers that are doing computing. Totally standard Hadoop on it. Just you have the data node on the storage servers, and you have everything about computing on the compute nodes. So this solution we had to test because we didn't know what we were going to see in terms of data transfer, the impact in terms of cost for the performance. And in fact, we have been very surprised because you have a bit of latency. Makes sense? To get to the data. But then we found out that when the nodes, these nodes, are doing only data node, they have only the data node service, they are only doing HDFS, they are working twice the speed that when they are doing HDFS and computing. It's just a matter of how this Intel architecture is working in general. And we have nodes that are very well optimized, but if you are doing storage, so managing the IOs and the data transfer, but at the same time computing, then it is a bit harder for the system. And we found out we have a bit of latency, but twice the speed in terms of HDFS. Then we have something that is faster than a standard Hadoop, surprisingly. And this was showing that it was possible. And there are features that came, and one of them we have been adding, or we have been working the same with WorldWorks to provide it to the open source. It is named the yarn labels. It is the capability to put nodes in one Hadoop cluster by group, to partition the cluster in terms of computing. The yarn labels or node labels are something that helps you, and it is available, you know, in HGP, and used by eBay, used by Yahoo, by a lot of people now. It helps you to separate different workloads. Because maybe you don't have the same server for the same workload. Maybe for the ETL, for the MapReduce, you will have small servers. For deep learning, Yahoo is doing deep learning with Flickr, recognizing what is on the photo. They are using GPUs. So there are a group of servers with GPUs, and you see the value of this type of architecture. You can have different type of servers in different groups. Could be linked to business units. You know, it could be an operational kind of approach, or it could be linked to what you are doing with them. You have big nodes with a lot of memory because you want to do machine learning. And with this type of architecture, you can make it. And you can make it easily. So you have a lot of elasticity. You have a very good TCO. And in terms of power, it is very efficient. In fact, to show you, this is a rack with DL380. And the DL380 is a server that is working very well. So we are getting, the comparison is done, we are getting the same performance with TerraSort. TerraSort is not the ultimate benchmark, but it is a common benchmark for Hadoop. With TerraSort, we are getting the same performance from these servers on the left and these servers with storage nodes. You see the storage nodes and compute nodes here. And these compute nodes are in Moonshot. You know the Moonshot I was telling you just before, with a lot of computing. You put whatever you want in terms of load on it, and you can adapt with your needs. Maybe you need a lot of data, but you don't need a lot of compute on it. Maybe you need a lot of computing, but not on a lot of data. So now you are able to grow your data, your storage, and your computing as you need. And this is great, you know, and this is really interesting. And with the constraints of the power usage. And you can run any type of workload on it. I mean, it's not limited to some workloads. You can run whatever. If you want to run Spark, MapReduce, HBase, Impala, Storm, whatever, Solar, you can. Now, what happens if we have a new component? An example of component could be Kudu. Maybe you have heard of Kudu. It's a low latency data store that is coming. So what about Kudu that is coming? Kudu is a data store. So maybe we will find out Kudu on the storage nodes, not on the compute nodes. So it goes where it makes sense to have it. And in terms of efficiency, it is the goal, you know. That's what we are getting, efficiency. Efficiency in terms of cost, efficiency in terms of processing. One of the components I was telling you about is Vertica SQL on Hadoop. So I don't know if you know that. So Vertica is a columnar database. I will go more in detail in the next slide, but it is a very powerful columnar database. So now we have a solution on top of Hadoop, not on top only of the asymmetric, what we call BDRA solution from HPE, on any standard Hadoop. And it is very efficient. And because we know how to make analytics, SQL analytics efficient on Hadoop, we have something that works very well. It is full NC. So you can take any test, any on the market, and you put it. It is very scalable, very powerful, and you are working directly on your Hadoop data. We have an ORC reader for the ORC files, you know, and we can work on these files, and it is very impressive in terms of performance. And one customer was telling me this morning, because they are there, was telling me that they found a fantastic performance, for example, using Hive on Tez on this type of platform, comparing with the standard platform, standard DL380 platform. So symmetric compared to asymmetric. So with SQL, Vertica SQL on Hadoop, you get a very, very efficient performance on this type of platform. Something that is interesting and important, you know, it is integrated with Embarray, and it is yarn ready also. So you have something that is enterprise ready. And when I say Vertica, you have the core of Vertica, so some components, that this is the core database of Vertica that is integrated with Kafka, with Spark, that is used and very efficient and used from less than 1 terabyte, because up to 1 terabyte it is free, to, I think, 6 petabytes, something like this, that the size of the data at Facebook that is running on Facebook, it is running on Vertica. So for some use cases, you will have Vertica Enterprise Edition, that is a standalone cluster by itself, and some other cases, you will have Vertica SQL on Hadoop, where you have your data. And then you will be able to do the analytics directly on Hadoop. It doesn't prevent to have 2 different types of systems. The Yellow Pages, for example, in the US, they have Vertica SQL on Hadoop, and then they have one database, one Vertica Enterprise cluster on the side. And it could be on the cloud, where they will have different offers. So what we see with these type of architectures and this type of application, we see that more and more people, they will have dedicated workloads or dedicated servers for different workloads. That's what happens already for some people. You have low-cost nodes. You are using them for standard processing, whatever. You have GPU nodes. I was telling you about Yahoo doing deep learning on the photos, you know, with Hadoop, Spark on Hadoop, and Café on Spark to use the GPUs. And then you could have something named FPGA. This is coming. If you need really very fast processing of data, FPGA is when you put the software on silicon. And Intel, a bit more than 1 year ago, they acquired a company to do FPGA. So we'll see FPGA more and more for very special type of application when you need really to fast data processing. But it will come. And you have big memory nodes and whatever. And you will see that more and more, you have this group of nodes with different type of workloads, different needs on the same cluster. And then you will have, on the storage side, you are going, and people are going to optimize the storage cost. And then more and more, you will have this storage tiering. And with this storage tiering, so you have hot data, warm data, cold data, and even what we could call frozen data that you will put in the HDFS erasure coding part. So you have one HDFS, you have writing on it, you just flag the files, the directories, and HDFS is moving the data for you. So if it's frozen, the day you will retrieve the data, it will be totally transparent, just it will be a bit slower. But if it is hot, when you get to the data, it is very fast. So with this type of architecture, we can use all these. Now, what about security in Hadoop? So in Hadoop, and in big data in general, if we are talking about the data, life cycle, I would say, very often you see that there are gaps in the security. For sure, you have security for the storage, you have security for the file systems, databases, middleware, data application, but as soon as you are getting the data out of one system to go to the next one, to go to another one, very often you have a problem with the security because your data is not secure anymore, is not encrypted anymore. And the only view or way, I would say, to manage data from the start to the end is to have a data-centric approach. And that's what we have with HPE Secure Data. So you might know Voltage Security. It's a company that has been acquired by HPE 1 year ago, a bit more than 1 year ago, I would say. So then with this type of technologies, with these solutions, with secure data, you can address really the data from the start to the end. And we are talking about the data, not about Hadoop or about Teradata, no, because the value really and what is great that we have solution for Hadoop, Vertica, Linux, Windows, nonstop, HP, Teradata, IBM. We are talking about the data lifecycle, It's data-centric from the start to the end. So your data is protected. And that is what is great with this solution. So in terms of key management, in terms of efficiency, this solution is used by a lot of banks, insurances, and it is really something that is very, very efficient. You don't need, it's stateless key management. You don't need a big key database, for all your keys. And you can do encryption and tokenization, depending on the need, depending on what you want to do. I will give an example just after. So with this solution, you can manage your data. You can encrypt your data with a lot of different ways, Just you put your data somewhere and it is encrypted by default. But what matters and what is interesting, you can make it really the way you want. If you want to keep part of the data readable, I would say, because you want to make sure that even keeping it encrypted, you can work on it, you can do kind of analytics on it, then we can make it. And it is really the beauty of this solution. So if we take this example, I would use what we call the secure stateless tokenization for credit card. Typically for that, it's PCI. It's about the PCI compliance, the payment card industry compliance. Then you can decide to fully encrypt or partially encrypt, and you see the difference, because there are some data that you want to be able to work on, to analyze, because they have value, because you can, without decrypting the data, you can work on it, you can get value out of it, and you can do it different ways, and this is really interesting. Or you can even decrypt only part of the data. That's also something interesting. In a lot of cases, you need to decrypt everything to be able to work on it. And there, you can decrypt field by field if you need. So different way to make it. So this is the secure token. And you have what is most used, I would say, when you don't have this PCI compliance, the need for PCI compliance. It's the format preserving encryption. So you are preserving the format. And this way, it could be used for personal information, the PII, for personal or protected health information. For PCI, it could be used in a lot of different domain and context. And then you can decide to fully encrypt or not, or part of the data. And it is very efficient to manage. And you have your data flowing, encrypted all the time. And at the end, when you need, it is very fast to decrypt. So this is a great solution that maybe you don't know that is named HPE Secure Data. And what about the services? Because it's good, to have platform, to have solutions. We have something that works. We know it works, but very often, and you know that, in the industry, a lot of people, they started to go for big data, but more from a platform tool point of view. So I'm sure I heard that big data is interesting for me. I can get value out of my data thanks to big data. I have to, or my competitors are doing it, I want to do it. It's an approach, but the problem is a number of people that are successful. And the best way to be successful is to have people that are really skilled people to help you doing it. To discover the value of the data, what we propose, is in different steps, different phases. The first one is to align the business goal and the challenge. So then, it's not about the platform. It's not about the detail of the solution. It's about what do you need? What type of data you have in the company? To understand really what the business needs. And you don't want to have any interruption of service or any disruption in the services. So you want first to align the business goals and the challenge. Once it is done, which means you're working with different business units and with people at different levels in the company, then you can have a view, start to have a view, and to see where you want to go. Maybe for the 10 coming years, And you have this, you can create a strategic roadmap to make it. So this way, you are looking to the future, what you need now, what makes sense for the company, and where you want to go. And then you can start to work on the data. And at the part so the two first part, this and this, we would call them data-driven transformation planning type of service, of offer, we're offering to our customers. And the last part about evaluate the data. So really, what do I have? What are the data I'm using or I'm not using? And why, and what makes sense, what has value, and may I find use cases now? And this is the part we call evaluate your data. It is named data discovery. And it's really interesting to understand because the first use cases, are key when you start to do big data. And if you are successful there, then you know that you will find some traction in the enterprise. So this approach is really the one we are pushing. A bit more in detail. You have discovery workshop. So this is the first part. So this is, I would say, a short workshop where you are really aligning the business and the IT. You see the opportunities. You see the priorities of each one. And you start really to see the different use cases you might test. And then you have the discovery experience, where you are going to start, to test, to create the use cases, the first use cases. You get the data, you know what you want to get, or you have an idea, and you know that you want to go to the next step. You want to be successful. When you have new use cases, at the end, there is 3 possibilities, I would say. Maybe you fail, maybe because you don't get the right data, or maybe because the use case is not the right use case, it doesn't bring value. You have, the second solution is you have an immediate interest in the use case, immediate value. It works well, it works perfectly from the first day. And this is really what sometimes we find out, not always, but sometimes just in the proof of concept, just in the POC, just starting to work on the data, the guys say, oh, but I'm learning something. I found something already. And then you want to put it in production or to use it as it is for some time. And the next step is where you see that it is interesting. There is a use case that is interesting with a lot of potential for the future. It's really potentially interesting. This one, you want to go to the next step. And the next step, and the other one also, the immediate value, and you want to put in production. And that the third part, discovery, production, implementation, to really operationalize what you did before. Doing it this way, an efficient way, is really a way to get success. Because once you did that already, and we see in general success, not for every use cases, but very often success. Because it starts from the business, and then we start to talk about the technologies, how to make it. And once you are to this stage, you might need something else. What we are offering here, what we call a data discovery lab. Data discovery lab is a kind of center of excellence, and we can work with you, with your customers, or even operate for them. It is the way to make the discovery experience, the workshop, and to start in new cycles with new use cases. The mean to start to work on it. So this is really key for the success of big data projects in the enterprise. Some example of customers, but you will find very often the same problems, the same need. If I take an example, the mining example, global mining service provider. Okay, mining. I don't know if you know that, but these guys have big trucks that are enormous. But when they have failures with these trucks, it costs a lot. It costs a lot in terms of production they lost, and it costs a lot just because of these kind of trucks that are, 5-10 meters high and very harsh. So they want to make sure they can do a preventive, failure on these kind of things. So if you want to have more details about use cases and customers, and so you just come at our booth, and we will give you more detail. So as a summary, I was telling you about the kind of infrastructure where, in terms of density, for the same size, you get twice the performance, or for the same performance, you have half the size. So something that is really optimizing. To give you, I wanted to give you an example of optimization in terms of architecture. Then I told you about the power of Vertica SQL on Hadoop that helps you to do SQL on your Hadoop, on your data, but a very efficient way with full ANSI capabilities to do the analytics. And then the way to protect your data. And if you have this, and everything in terms of data management, data discovery, to help you to put in place this, then it could be a success. So, to finish, I would say, why Hewlett Packard Enterprise, why HPE? We're talking about experience and expertise, and it could be really, it has a lot of value. Solution leadership. We're talking about the analytic database. By the way, Vertica has been the first columnar database. It has been created by Michael Stonebreaker, who did PostgreSQL also. So interesting solutions and powerful solutions, then market leadership, and flexible and open solutions. And we are really committed to open source and integrating our solution with open source product, pushing IP when it is possible in the open source. So I'm done with the presentation, but I would be very happy if you have questions. Yes? Excuse me, maybe I'm not sure. Oops.
Is it working?
Okay. Oops.
So on your Vertica enterprise, you have obviously a community edition so people can try it and get used to it. Do you have a similar for the Hadoop offering?
For Hadoop?
For your Hadoop, SQL on Hadoop offering.
That's it. That is Vertica. Ah, no.
Do you have a...
I heard about something, but I'm not sure it is available as such. I heard about something. I don't think we have it like available right now. Not yet, I would say, I think.
And can you integrate both your Vertica on Hadoop with your Vertica Enterprise so you get a federated query?
Yes, Vertica, anyway, first, Vertica does integrate very well with Hadoop, anyway. So for sure, it is even more simple if you have Vertica SQL on Hadoop and Vertica Enterprise Edition. That's what are doing the Yellow Pages in the US. They did huge clusters on Hadoop and then on Vertica, and they are really leveraging the power of Hadoop for some type of workloads, and then using Vertica when they need a lot of speed and a lot of power. Yes?
I have a question. In the secure HPE.
Secure data.
Yeah, secure data. When you run an application in Flink or Spark, the data is secure in HPE or?
And you have the integration with Spark, so you can get your data and decrypt the data very fast when you need, depending what you need to do.
Only Spark, but Flink?
You do with Scoop, Spark, HBase, well, a lot of components.
But not Flink?
I don't know Flink. I don't think Flink. I don't think.
Yeah. Okay, thanks.
Thank you. Some other questions? Okay. So anyway, I think it's time. So thank you very much for coming and have a good event. Thank you.